Hello, everyone. I am a teacher from Jiangxi Environmental Engineering Vocational College, Diao Xin Xing. Today, I will tell you the course of Water Pollution Control Technology. Biological Treatment Technology Part. Theory of Biological Phosphorus Removal. Purpose and method of phosphorus removal from sewage. The existing forms of phosphorus in sewage mainly include orthophosphate, polyphosphate and organophosphorus. The sources of phosphorus mainly come from feces, detergents and some industrial wastewater. In the general secondary treatment effluent, total phosphorus, normally 1 to 2 mg per liter. Phosphorus is similar to our nitrogen. It can also be used as a nutrient element of plants. On the one hand, it is an important fertilizer for our plants and crops. On the other hand, if the phosphorus content in water exceeds the standard, then it will also lead to eutrophication of water bodies. Therefore, the purpose of phosphorus removal, it is to prevent rich oxidation of water body, and the harm to organisms in water. Method of phosphorus removal from sewage. It can also be divided into chemical method and biological method. Let's learn about sewage today. Principle of biological treatment. Phosphorus in sewage can be removed by accumulating bacteria in sewage. So how do phosphorus accumulating bacteria remove phosphorus? Let's take a look. First, phosphorus accumulating bacteria can release phosphorus under anaerobic conditions. It can put phosphorus in organic state can be released into phosphorus in inorganic state, release it back into the water. At the same time, it will also form some intracellular carbon sources. Then in the aerobic state, our phosphorus accumulating bacteria can absorb phosphorus aerobically. It can convert inorganic phosphorus in sewage. Phosphorus accumulation in the organic state of cells formed by absorption. At the same time, it will decompose its intracellular carbon source, and accumulates a certain degree of ATP. Then as shown in the figure, this is our phosphorus accumulating bacteria, and phosphorus accumulation in phosphorus accumulating bacteria. Key design parameters of biological phosphorus removal process from wastewater. We can see that there are mainly hydraulic retention time. In the anaerobic zone, it is generally 0.5 to 1.5. The aerobic zone is generally 1 to 3 hours. Its sludge age is different from that of biological nitrogen removal sludge. The sludge age required for biological phosphorus removal is generally short, in 3 to 7 days. Then the concentration of suspended solids. Generally, it is between 2,000 and 4,000 mg per liter. Reflux ratio of sludge. Generally between 25% and 100%. Control conditions of biological phosphorus removal process from wastewater. First, pH. We generally require a range of 6.5 to 8.5. DO requires near 0 mg per liter. This means that the temperature in anaerobic environment is 10 to 30. The sludge age is generally required to be 3.5 to 7 days. The ratio of BOD to phosphorus is generally required to be greater than 15. Then the control of nitrate should be determined according to the process. Because nitrate, it will destroy the anaerobic environment of the anaerobic tank in the anaerobic tank, thereby affecting the removal of phosphorus. Then let's look at a typical AL phosphorus removal process. We can see that wastewater will first enter the anaerobic tank. Anaerobic phosphorus release occurs here. Then it will enter the aerobic tank. Aerobic phosphorus absorption can be carried out in aerobic tank, immediately after entering the secondary sedimentation tank. Sedimentation in the secondary sedimentation tank. After precipitation, then phosphorus in sewage. It is absorbed by phosphorus accumulating bacteria. Therefore, phosphorus in sewage can be removed in large quantities. Then let's leave a thinking question for the students. Secondary sedimentation tank. Is there any requirement for its precipitation time? How long will it be appropriate to set it? Give everyone a little hint. If the sedimentation time of the secondary sedimentation tank is too long, so it is easy to cause anaerobic in the secondary sedimentation tank, then it is possible to gather isolated bacteria. Phosphorus will be released in anaerobic environment. It will lead to excessive phosphorus in our effluent, then as shown in the figure. This is our AL process. A graph of BOD and phosphorus biotransformation. We can see that there is a slow decline in BOD in pool A. In this process, it is mainly the easily degradable organic matter in sewage is removed. So in the O pool, there has been a large decline in BOD, that is to say, a large amount of BOD will be removed in aerobic tank. Then see the phosphorus in pool A. Phosphorus in sewage is on the rise. It just coincides with the release of phosphorus in our anaerobic tank. Therefore, the phosphorus in sewage is increased. So in the O pool, phosphorus accumulating bacteria are in an aerobic state of phosphorus absorption. It will absorb phosphorus in sewage. So phosphorus in sewage, will it be in a downward trend? Finally, the phosphorus in the effluent is guaranteed to reach the standard. We can also see this picture. This is a schematic diagram of AL phosphorus removal process. You can see that among them, there is a lot about orthophosphate VFA phosphate and our PHA, one of their changing curves. Next, let's look at a phosstrip process. General AL phosphorus removal process. It has certain limitations. That is the sludge precipitated from the secondary sedimentation tank, returned to the system through the return system. Then the sludge precipitated in the secondary sedimentation tank. It absorbs a lot of phosphorus. It flows back into the system. At the same time, it will also absorb the phosphorus absorbed in the early stage, back to the system again. So how to deal with this problem? To bring us, the cleansing effect of the whole system is greatly improved. So we see the phosstrip process. Phosstrip process. It can take the sludge precipitated in the secondary sedimentation tank, enter an anaerobic phosphorus release process. Then after anaerobic phosphorus release, again, phosphorus released sludge is returned to the system. At this time, the sludge is basically phosphorus-free sludge. Then this sludge enters the system again. Its phosphorus removal effect will be greatly improved. After anaerobic phosphorus release, the phosphorus in the supernatant will be relatively high. What about this? We can put the supernatant, introduced into another chemical reaction tank. We can add some phosphorus removal agents here. Let the phosphorus in the sewage be precipitated. Then it immediately enters the sedimentation tank. Phosphorus is precipitated by passing it through a sedimentation tank. Then the remaining wastewater containing almost no phosphorus. Once again, we let it go back to the biological processing system. This is the phosstrip process. It can greatly improve the effect of phosphorus disposal in organisms. Alright, that's all for our lesson. Thank you all.